Hey guys, welcome to the 13th tutorial of data structures, and today we are going to see what is a stack ADT and what are the types of implementation and operations available in a stack ADT. Okay. So we all know that stack ADT is a linear data structure, and with stack ADT we are having list ADT and queue ADT. So far we have completed list ADT and all its components. And in stack ADT, it has been classified into two types of implementation. Stack ADT is a concept. It can be implemented in two ways. Okay, so we can implement it in array implementation and linked list implementation. Either in array implementation or linked list implementation. Okay, so stack ADT is a concept where we can implement those concepts in through array concepts or through linked list concept. Okay, so what is a stack ADT? Stack ADT is nothing but a linear data structure where it follows the operation of first in last out or last in first out. Let me tell you clearly. So let's assume this is a stack data structure. Okay, so we can see that only one opening is there in this data structure. We can either insert the element or delete the element through that opening only. Okay, so if we are going to insert an element, the operation is called as push operation. If you are inserting an element into the stack, we are inserting one element. For example, if we are inserting the element 10, so the first element inserted will be inserted in the data structure, and next element 20, 30, 40. So likewise, we are pushing the elements inside the data structure. So this push operation is called as insertion process in the stack ADT. Okay. Next process is called as pop operation, where POP, where pop indicates deletion of a element from a stack ADT. Okay. From the data structure, we are removing an element. So which is the element inserted as the last element is being deleted as a first element. Okay, so for example, 40 is the element which is being inserted at the last. So last in goes out first. So first element to come out is 40. Okay, so after 40, 30 comes out. Pop. And the last element to come out is the first element to be inserted, which is the first element inserted is 10. So after deleting 40, 30 and 20, we are removing 10, which means the first inserted element comes out last. Okay, so this process is called as first in, last out. Okay, or the last one in, first one out. So last in, first out, or first in, last out. So this process is called as stack ADT. Okay. Now, what we are going to see in this tutorial is how to perform these push operation, pop operation in array implementation and linked list implementation. Okay. Now, let us take a real-time example. So, this is a CD case. Okay. So, I am going to compare this CD case with a stack data structure. Okay. So, for example, so we can tell that this is a stack ADT, okay, where we have only one opening, okay, and the stack is empty so far. There is no element inside it, okay. We can also consider this as a data structure, stack data structure, where we are having one pole in the middle. So we are having just one inlet and outlet which is through the top, and there is no opening at the bottom. Right. So if you want to insert any element or delete any element, it's only possible through the top position. Okay. So let us take this as an example for insertion and deletion. Okay. Now let's assume there are 200 CDs or 100 CDs available in this pack. Okay. The first CD inserted is the one at the bottom, the last one available in the CD rack. Okay. Now if we are going to delete the element one by one, okay, the last element which is being deleted will be the first element which has been inserted already. Okay, so this concept is called as first in, last one out. Okay, so this structure is called as stack data structure or stack abstract data structure. Okay, stack ADT. Now, what we are going to do is we are going to perform the push and pop operation. Now, how to perform those push and pop operation? Now, let us assume we are having a stack. Okay, and this stack is being compared to a array process, right? So first process is array implementation. So 1, 2, 3, 4 and 5. So let's assume we are having an array with size of 5. So starting from 0, 1, 2, 3 and 4. Okay. Now insertion and deletion is always done through the top portion. Now what is top? Now this is an empty stack. Before seeing the operations of push and pop, we have to go through two conditions. What are those conditions? Stack underflow and stack overflow. Now what is stack underflow and what is stack overflow? Which means if in this case, so this is a deadline, okay, so where you can see the end mark, after which we can't insert any CDs, okay, so I am inserting till that value, okay, after which we can't insert any CDs or DVDs in this case, okay, so which means that in this data structure the stack is full, we can't insert any more CDs in this stack, okay, so which indicates that if I want to insert any new CDs I can't. So that process is called as overflow. So we can't insert any elements in a full stack. Okay, so we can't insert any element in the full stack. Okay, so that is called as stack overflow. Okay, and similarly, while deleting each and every element, if I have deleted all the elements, okay, I am having an empty stack, and if I want to delete any element, there is no element available in the stack. So this concept is called as stack underflow. When you want to delete an element from the stack and you can't delete any elements, then it is called as stack underflow. Okay, so stack overflow is you can't insert any element in a full stack, and stack underflow is a condition where we want to delete an element from an empty stack. Okay, so these are the concepts of stack overflow and stack underflow. Now, before the next concept is push and pop. So before going to the push and pop, what we have to know is we want to know a term called as top. T-O-P. Now what is top? Top indicates the level of elements available in the stack. Okay, so for example, it is an empty stack and we don't have any elements. So which means that top is equal to default value minus 1. Because if top is equal to 0, it indicates that there is a 1 value available in the stack. So top is equal to minus 1. Okay, so step 1, push 10, which means that we are going to insert a value 10 inside the stack. So we are going to push an element 10 inside the stack. Okay, so now what happens to the top is the top equal to minus 1. We have already inserted a value in the top, in the stack. Right. So what happens to top is from top is equal to minus 1, top gets incremented to 1 value. So top indicates the topmost value available in a stack. Right. So top is equal to top plus 1, which means that the new value of top is equal to old value of top plus 1. So minus 1 plus 1, the value is 0. So at this case, top becomes 0 at the position of 10. Okay, now next condition is we are going to insert another value, push 40. So we are going to insert in the second value 40. So again top is equal to top plus 1, the value of top gets increased. Okay, so top is equal to top plus 1, so 0 plus 1, 1. So top is equal to 1. So the value of top goes to 0 to 1. So similarly, after inserting the values 50, 60 and 70, 50, 60 and 70. Okay, the top goes to 2, 3, 4. So top goes to position 4. So this is the process of push element in array implementation of stack ADT. So here we are seeing the concepts of stack ADT, where we can implement the concept of stack ADT in array implementation. Okay, array implementation. Okay, so we are pushing an element so far. So we are pushing the element and the top is equal to the size of the array. When top is equal to size of the array, then it means that the stack is full. We can't insert any more element. Stack overflow, all those kinds of things will be coming up. Okay, so now what we are going to do, we are going to delete all the elements. So the delete process is done by pop operation. So we are popping an element. So the pop operation indicates that the element top will be removed first. So if here the command is, we are instructing the operation push and we are inserting an element which has to be inserted. But in case of pop, what element has to be deleted is unnecessary, because anyhow the element which is available in the top position is going to be deleted. Right? So for deleting the element, the topmost element, we are using a pop operation. So if pop operation, top is equal to top minus 1. So the top element comes over here. So 70 is being deleted. Again, I am using pop operation for 4 times. Okay, so top is equal to top minus 1, 1 time, top is equal to top minus 2, top is equal to top minus 3, and top is equal to top minus 4. So 4 times I have deleted. So I have deleted all the values, and now the value of top is equal to. So in this tutorial we have seen stack ADT concept by implementing it in array implementation. So in array implementation we have done the operations of push, pop, and how the top works on while committing all the operations, right? So in next tutorial we will be seeing the implementations of push, pop and top of stack ADT in linked list implementation concept. Okay, so until we meet in the next tutorial, it's Karthikeyan signing off.